All right, good morning, everyone. My name is RogerBain, and I'll be presenting my final research project titled Rising from the Ashes, a dual index analysis of environmental controls on Mediterranean post-fire recovery. This research challenges assumptions about how ecosystems recover after wildfire and provides new methodologies for fire management. In today's presentation, I'll be covering the study area, my research questions, workflow, data and tools, time series analysis, slope and aspect analysis, results, and conclusions. In 2016, the Blue Cup fire burned over 37,000 acres in San Bernardino County, California, between August 16th and August 26th. This fire closed Interstate 15 for nearly a week, stranding thousands of commuters between Southern California's high desert and Los Angeles. This showed how vulnerable our infrastructure is to wildfire, but it also created a unique opportunity to study ecosystem recovery. The study area spans elevations from 742 to 2,113 meters, creating different climate conditions that affect how fires burn and how areas recover. This elevation range provided a natural study area for Mediterranean fire ecology across varied conditions over 9 years of recovery. This map also shows the fire's relationship to major transportation corridors, including Interstate 15, Highway 138, and the BNSF Railway. The infrastructure impacts show why understanding post-fire recovery patterns matters for both environmental and economic reasons. My 4 key research questions for this project were: 1, how do NDVI and MBR recovery patterns compare across 9 years, and what insights emerge from dual index validation? 2, which environmental factors most strongly influence recovery rates? 3, do gentle slopes outperform flat slopes in post-fire recovery, contradicting conventional erosion control theory? And 4, how do slope and aspect interact synergistically to create optimal recovery zones? For my analysis, I used 9,475 randomly distributed sampling points, which is the largest sampling framework in Mediterranean fire ecology literature that I could find during my research. This provided greater than 99% statistical power for detecting even small effects, ensuring reliable statistical results. Comparing this to previous research, a study by Ming et al.'s remote sensing analysis of post-fire recovery using NDVI regression analysis achieved an R-squared of 0.64 over 2 years with much smaller sample sizes. In another study, Singh and Vogler's machine learning study of post-fire recovery using random sampling methodologies reached 0.945 over 5 years. My dual index approach achieved an R-squared of 0.9687 over 9 years, representing an incremental improvement and a breakthrough that exceeds previous research by 2.5%, while also extending the time scope by 80% and providing independent cross-validation through dual indices. This large sample size was important because it allowed the detection of subtle environmental relationships that smaller studies might miss. The random distribution ensured unbiased representation across all slope classes, aspect orientations, and elevation ranges within the fire. My workflow integrated automated data processing, dual index vegetation analysis, environmental controls assessment, and statistical modeling. The key innovation was combining NDVI and MBR for independent validation. The multiplicative environmental controls framework captured how slope and aspect work together in relation to vegetation recovery, moving beyond simple additive models to understand ecological interactions. I utilized 6 Landsat images from pre-fire baseline, immediate post-fire impacts, and recovery periods at 6 months, 1 year, 5 years, and current status. The data was downloaded from the USGS Earth Explorer website with consideration of images that had minimal cloud cover to ensure data quality. The fire perimeter was obtained from the National Interagency Fire Center's Archive of Historic Fire Perimeters from 2016. I used the USGS 3DEP 10-meter high-resolution digital elevation data for accurate calculation of slope gradient and aspect orientation. I utilized the National Land Cover Database through ArcGIS Online to document vegetation transitions from 2016 to 2024. And finally, I used ArcGIS Python integration for automated processing of several raster products, helping to ensure temporal consistency and systematic accuracy. This helped to minimize processing errors that could have affected the reliability of the dual index analysis. This NDVI time series analysis shows 98% natural regeneration with 114% mean recovery of pre-fire conditions. You can also see that there was rapid initial recovery followed by steady improvement through 2025. When corrected for seasonal timing, since the last available Landsat images were from May 2025, the true recovery rate still reached 93%. This represents near complete restoration and demonstrates the resilience of Mediterranean fire-adapted ecosystems. The NBR time series analysis provides independent validation with 80% improvement from immediate post-fire conditions. Correlation between indices exceeds 82% across all time periods, confirming NDVI findings through a complementary analytical approach. From the images, you can see that there is a progressive burn severity reduction from post-fire to current conditions. The most significant discovery from the analysis was that gentle slopes outperform flat slopes in terms of recovery. Traditional theories suggest flat slopes should recover best due to less erosion and better water retention. However, both NDVI and NBR analyses reveal that gentle slopes consistently outperform flat slopes. Looking at the data, gentle slopes achieved 114.2% NDVI recovery compared to 108.5% for flat slopes, a 5.7 percentage point difference. For NBR, the difference was even greater. Gentle slopes achieved 100.1% recovery compared to only 70.2% for flat slopes, a 29.9 percentage point difference. Quadratic regression modeling achieved excellent statistical validation with R-squared values exceeding 0.95. The aspect analysis revealed that west-facing slopes achieved the highest recovery at 113.9% NDVI and 99.6% NBR. This reflects the beneficial effects of afternoon moisture retention in Mediterranean climates where west-facing slopes receive afternoon sunshine but avoid the intense morning heat that can stress recovering vegetation. The statistical significance of these findings was confirmed through circular regression analysis, which properly handles the directional nature of aspect data. Both NDVI and NBR analyses achieve strong explanatory power with R-squared values exceeding 0.84. NDVI spatial analysis shows the progression from pre-fire to post-fire devastation to substantial recovery by 2025. The green areas indicate successful vegetation recovery, with the darkest green representing areas that have exceeded pre-fire vegetation density. NBR analysis shows the transition from high burn severity in red to progressively lighter colors indicating recovery over time. What's particularly notable is that there are more lighter areas on the current map than in the pre-fire map, indicating that some areas now have higher vegetation moisture content and lower fire risk than before the Blue Cut fire event. The multiplicative environmental controls framework demonstrates how environmental factors work together rather than separately. This proves true synergistic interaction. Some key combinations include west-facing gentle slopes achieving 130.1% recovery, which represents a 14% enhancement over individual factor effects. South-facing gentle slopes achieved 129.6%. West-facing moderate slopes reached 121.9%, and although north-facing steep slopes achieved 103% recovery, it represents the lowest percentage among successful combinations. The vegetation classification demonstrates a notable shift from herbaceous to shrubland communities, representing healthy ecological succession. Pre-fire grasses and wildflowers have transitioned to shrubs and bushes, which is the natural succession pathway in Mediterranean fire-adapted ecosystems. This transition shows that the ecosystem is following expected recovery patterns. Finally, this Sankey diagram visualizes vegetation transitions from 2016 to 2025, confirming successful transitions to appropriate post-fire vegetation types. The diagram shows that most vegetation types are transitioning toward more mature fire-adapted communities, indicating healthy ecosystem development rather than degradation. To conclude this presentation, there were 5 key findings. First, there was 98% natural regeneration achieved across 9 years, proving that fire-adapted ecosystems can fully recover without intervention when environmental conditions are favorable. Second, gentle slopes consistently outperform flat slopes, contradicting conventional erosion theory, which was validated across both NDVI and NBR analyses. Third, NDVI and NBR analyses achieved 82% correlation across all time periods, with 94% cross-validation accuracy, establishing new standards of methodology for fire ecology research. This dual index approach provided independent verification of recovery patterns that single index studies cannot achieve. Fourth, synergistic slope aspect interactions explain 95% of recovery variation. The multiplicative environmental framework captures interactions that linear approaches failed to detect. And fifth, this is the first dual index study with 9,475 sampling points over 9 years, achieving an R-squared of 0.9687, exceeding previous research. Thank you all for being here, and I welcome your questions.